Okay, so let's just review. We're on 5-1 piecewise. We talked about our piecewise function that looks like this. We explained that there were 4 parts to that piecewise function because there are 4 different rates of change. That's why you needed 4 different equations for it. We started to write, we wrote the first equation for that first part. Now we're going to write the next equation. So here's our graph. We're going to deal with number 2, writing that equation. Number 2 is a horizontal line. So it's just a y equals, whatever the y value is there. And what is the y value? It's at 3. If you extend that line, it will touch the y-axis at 3. So it's y equals 3. Any questions? Okay, the next piece is right here. We want to find the slope. So we're going to rise and run. Rise and run. So it's 1/1 and everything's positive. So my slope is 1. Okay. I'm going to come here. M equals 1. Okay, then we need the y-intercept. Does this cross the y-axis anywhere that I can see? No, it doesn't. Okay, so I don't know the y-intercept. So I need to use the point slope formula. So I need the slope and a point. And I'm just going to use that first point that it starts on. You can use any point on that line. I just tend to use the starting point. So that point is 8 and 3. 8 for x. And 3 for y. And again, we have to find a point because I cannot find the y-intercept. I don't see the y-intercept from the graph. So I'm going to plug it into y minus y1 equals m times x minus x1. This is my x1 and this is my y1. I'm going to plug it in. So y minus my y1 is 3 equals my slope of 1 times x minus my x1, which is 8. And distribute. I'm going to get y minus 3 equals x minus 8. Plus 3 plus 3. And I get y equals x. Negative 8 plus 3 is negative 5. So this is my equation for that line. It would cross the y-axis at negative 5. Okay, the last piece of that. Number 4. Okay, again, we need the slope. So this time I'm going down 2, so it's negative 2, and to the right 1. I can try it again, make sure, down 2, and to the right 1. So my slope is negative 2. Looking at that graph, can I find the y-intercept? No. So I'm just going to use that point that I have, which is 12 and 7. So my slope was -2. My point, my y-intercept I couldn't find. So my point was 12, 7. Is that right? Is that what I said? Okay, again, we're going to plug it in to y minus y1 equals m times x minus x1. So I'm going to get y minus, I go x1, y1. Y minus 7 equals my slope of -2 times x minus 12. Then we'll distribute. Get y minus 7 equals -2x. A negative times a negative makes that positive 24. Then I add 7 to both sides. And I get y equals -2x plus 31. So those are all my equations, all 4 of my equations for that one graph. Okay? And that's how it works for piecewise functions. They'll have they can have as many parts as they can. They could have 2, they could have 15. Okay? And you just have to find all of the equations for them. Okay, so we're gonna do another one. Okay, write a piecewise function for the following scenarios. A t-shirt company charges $20 per shirt for the first 10 shirts. After 10 shirts, they charge $15 per shirt. After 20 shirts, they charge $10 per shirt. Write a piecewise function, P of X, for the total cost of the shirts for X number of shirts. So again, this time I have 1, 2, 3 pieces that I need to write an equation for. Since I have the scenario, you might want to look back at the scenario and that will help you with some of the information as well as the graph. So for that first one, we want the slope. Remember, the slope is like the rate of change, or it is the rate of change. So what rate are these shirts being sold at for the first one? $20, okay? So you don't even have to look at the graph. You just look at the equation. The rate at which they're being bought at is $20 per shirt. If you weren't sure, you could also look at the slope. I'm just going to go from point to point because that's the easiest thing to do. I went up 200, and then to the right, they're counting by 5, so 5 and 10. So it was 200 over 10, which reduces to 20. Okay, which would reduce to the 20 that we've already found. We need the y-intercept. And what's the y-intercept here? 0. Which makes sense because can I buy a -1 shirt? I can't buy negative amounts of shirts. The smallest amount of shirts I could buy is 0. So it's going to cross the y-intercept at 0. So then we plug it into y equals mx plus b. And then we get y equals 20x plus 0. That's my equation. Now, because this line doesn't continue on and forever go up at a rate of 20 per shirt, we need to have a domain for it. For this equation, the domain has a beginning and an end. Okay. So what are the X values? How many shirts can I buy? What's the smallest amount of shirts I could buy? 0. Okay. What is the most amount of shirts I can buy at $20 per shirt? 10. Okay. And I can equal 0 and I can equal 10. So it's less than or equal to X. So the domain for this is 0 is less than or equal to X is less than or equal to 10. Any questions? Okay. Number 2 equation. The number 2 equation has a different rate. Now for this equation, how much am I spending per shirt? $15. After 10, I'm buying them at $15, a rate of $15 per shirt. Can I see the y-intercept? No, I don't see where it's crossing. So I need a point. So I'm going to use that beginning point here that I started with of 10 and then 200. Now I'm going to plug it into y minus y1 equals m times x minus x1. I should have told you this earlier, but you want to write small because it's going to be hard to squeeze all this in. So if you started writing bigger, scrunch it in, you guys. So we're going to have y minus my y1 is 200 equals my slope of 15 times x minus my x1 is 10. Now I'm going to distribute. I'm going to get y minus 200 equals 15x minus 150. I'm going to add the 200 to both sides. And I'm going to get y equals 15x plus 50. Then I need my domain for this one. And again, remember your domain is your x values. What are your possible x values for this equation? And we want where it starts and where it ends. Okay, my first, so it starts at 10 and it ends at 20. Does that make sense? From here to here, and it's always the x value, not the y. So 10 and 20. So let's review if they can be equal to that or not. At $10, or sorry, at $10, at 10 shirts, how much is that? Am I paying for that 10th shirt? Am I paying $20 or 15? 20. It says right here after 10. 10's not after 10. So on the 10th shirt, I'm still paying $20. So you don't have an equal sign here. You just have a less than sign. For the 20th shirt, am I spending $15 or $10 for the 20th shirt? 15, because after 20, I'm going to start spending 10. But at 20, I'm spending 15. So I need an equal sign on this one. Any questions? Okay, number 3. Now we'll go back to our equation again. After 20, they are going to start charging me now $10 per shirt. So that's my rate. And again, I don't see a y-intercept for this. So I need to use my point. And I'm going to use a point right here. And my point is 20 and 350. Any questions? So we get y minus y1 equals m times x minus my x1. We're going to plug it in. Y minus 350 equals 10 times x minus 20. So then we'll distribute. I'm going to get y minus 350 equals 10x minus 200. Add the 350. And I get y equals 10x plus 150. Any questions over that? Okay, now I have to go back to our domain. Notice that it has the arrow on the end. That means it's going to go on forever. So there's not going to be an end to this. So then we don't have a start and a stop for my domain like the others had, like this one and this one had. Where does my domain start for this equation? Okay. Right here at 20. So x and 20, can x be greater than 20 or can x be less than 20 for this graph, for this equation? Are these numbers going this way to the left of 20? Oh no, that's to the right, sorry. To the right of 20, are those numbers bigger than 20 or smaller than 20? Do we all understand that those are bigger? Okay, so it's greater than sign. And again, at the 20th shirt, I am still paying $15 per shirt, not at the rate of 10, so it doesn't have an equal sign. It's just X has to be greater than 20. All shirts after 20 are going to be $10 per shirt. Any questions over that? Now I have to squeeze one more thing in here. This is how you write a piecewise function. If you can squeeze it somewhere in here, squeeze it somewhere in here. I'm going to put it down here. You have f, oh, in this case, they don't want f of x. They told us p of x. So that's what we're going to be using, p of x. So p of x equals, I'm going to use the big old bracket thing. We start with the very first equation that we wrote, the 20x plus 0. And we just need the 20x. I don't need to write in plus 0 because that's implied. So it's just 20x. Then you use a semicolon and write the domain. Okay, then we're going to take the next equation, number 2, which was the 15x plus 50, and that goes next. Then put a semicolon, and the domain 10 is less than x is less than or equal to 20. Then we take finally that third equation and get 10x plus 150 with a semicolon, and the domain of x is greater than 20. And that is my piecewise function. This is how I could figure out how much I'd be making if I owned this business, selling however many shirts by having this wonderful piecewise function. Any questions? Okay. Now we're going to move on and just, given a graph not connected to any scenario, we are going to write a piecewise function for this wonderful graph. Any questions over that? Okay, for that first piece, we're going to number them. This is 1. This is 2. Let's see. 2. This is 3. First thing we need to do when we're looking at this is determine if this is a linear, that first number 1, my first graph here, is that a linear equation or a quadratic equation? Linear. Hopefully you should all know that what a linear equation is by now. It's a line. This clearly is a line. So that means my equation is going to look like this. Y equals mx plus b. So for this, I need my slope. Everyone trying to determine the slope for me? Okay, in class, what is the slope? 1. Good. Now I want to check to see, does it have a y-intercept? No. Could we kind of see where it's going to cross the y-axis if it continued on? Yes. So if we can see that, by all means, kind of see that this would extend and cross at 3. So b equals 3. Even though it doesn't, I can see that it would eventually cross if it continued on. That saves me from having to do the y minus the y1 equals m times x minus x1. So I can just plug this in now to y equals mx plus b and get y equals 1x plus 3. Any questions over that? So now again, we want to write the domain, and we want to know where does x start and where does it stop. So I put x, I have less than. Okay, before we do that, we need to review. I'm gonna write this up here. Do you remember back like in maybe 5th, 6th grade, and you had to graph this? Not -5, let's just do +5. You were given equality, x is greater than 5, and you drew it on a number line. Put 0 here. And then like you did 1, 2, 3, 4, 5, right? Okay. Does you remember how we graph that? How would I graph x is greater than 5? Alexis? Ooh, and why is it an open circle? Because it's not equal to. Okay, if you notice on my graph, I have open circles and closed circles here. Okay, so that's why it's open and closed circles. Because back to this, it's an inequality. So let's just review. Greater than and less than are open circles because they cannot equal that number. They get really close to that number, but they cannot equal it. Greater than or equal to and less than or equal to are closed circles. Let's just review that that is a greater than sign. It's greater than or equal to, and this here, just in case we forgot, is a less than sign, less than or equal to. So for the domain here, we need to look at the x values. So I kind of just draw a line where my point starts. And you see right here is where my line ends. So I'm going to draw a vertical line down. And I just want to see the x values there. So what is my x value here, class? -4. So that's where it starts. And at -4, can it equal -4? Yes. Sebastian, why can it equal it?
Because it's a closed circle.
Yes, closed circle. Then we go back over here. Now we want to see where it ends. So here again is my point that it ends. I kind of go down to see what the x value is there. In class, what's the x value there? -1. Okay, but can it equal -1? Let's look back at our dot. Open circle, so can it equal it? No. Okay, so it doesn't have a line underneath it because it's an open circle. Does that make sense? Okay, and that's the domain for that. Fairly simple. I know you guys are all saying, no, that's not. You'll get it the more we do it. This is brand new, so I get that. Okay, next one, number 2. So now we're on to this part of our graph. Hopefully we know, is this linear or quadratic, class? Quadratic. Hopefully you know now that that clearly isn't a line, so it can't be linear. Our other option that we know right now is quadratic. And we just graphed quadratic, so hopefully you remember that they are parabolas or U-shapes. Okay. And our equation for a quadratic is y equals a times the quantity of x minus h squared plus k. That's quadratic in vertex form. So to write the equation of this one, we need our a value and we need our vertex. So does anyone know what the vertex would be here? Very good. 1 and then -3. If you're not sure, remember it's right here. It's the minimum value. It's 1 for x and -3 for y. The a value, remember when we graph these, our patterned rate of change for quadratics was a over 1, then 3a over 1, then 5a over 1. So to find the a value, you go over 1 and up the a value. So how far up did I move? 1. So my A value is 1. We plug it in to our vertex form of a quadratic, and we get 1 times x minus, the h value is 1, squared, and then the k value is negative 3. Remember, this is your h and this is your k. And then the negative 1, in parentheses, we change the signs. So it was in the vertex a positive 1. When I plug it into the formula or the vertex form, it changes to a negative 1 inside those parentheses. Moving on to the domain. Domain is where does the x start and stop. We always start off with the x in the middle and our less than signs around it. We want to see the x value where that parabola begins. Okay. Alyssa, what is the x value where that parabola begins? Negative 1. And looking at my dot, can it equal negative 1? Yes, and why can't it equal it? Let's go back to where we talked about where it can open and close circles, right? Because it's a closed circle. And closed circles mean it can equal that number. Okay, then we're going to go back to where that parabola ends. Brooke. Okay, it's ending at 3 for the x value. Right there at 3. Okay, can it equal it? No, and why not? It's an open circle on that 3. Any questions over that? Okay. Last one, our linear or quadratic. That last piece of our graph, of our piecewise function. Is that a linear equation or a quadratic? Linear. It is a line, so it's linear. So we're back to y equals mx plus b. So again, we need our slope. And this slope's a little bit tricky because it kind of meets in the middle and not on it. So we have to go down a whole 1. And since we're moving down, it's negative. And this, right, if I drove a car here and all of a sudden I would go downhill, so that's a negative slope. And then I would have to move over 2 to get my slope. So my slope is down 1 and over 2. And sorry, not just over, but right 2. Now, can I see my y-intercept here? No, and this is going to be hard because my graph doesn't go any further and it's going to be hard to count backwards. So I'm not going to be exact. So we do need to use our point. And I'm going to use the point that's right here. So that's the only one I can see. which is 4 for x and 2 for y. Do you notice I wouldn't use this point because it has a fraction in it, or this point because it also has a fraction in it. So I need to get the one that is just whole numbers. And I'm going to plug it into y minus y1 equals m times x minus x1. So you're going to have y minus 2 equals negative 1/2 times x minus 4. Keep going. I'm going to move this up here. Y minus 2 equals negative 1/2 times, well, let's distribute 1/2 x. And then what? Negative 1/2 times a negative 4. A negative times a negative makes that positive. And 1/2 of 4 is 2. Half of 4 is 2. Then we have to get the y by itself, so we add 2 plus 2. And I get y equals negative 1/2 x plus 4. Any questions over that? Now we need our domain. We look at the graph. If you notice, this graph is going to go on forever. Okay, so I don't have a stop point. I do have a start point though. So x begins here at this dot, which is at 3 for the x. And since it goes to the right of 3, that goes on forever. And that's bigger. So it's greater than 3. Class, is this going to be an equal to or not equal to? Let me hear you guys say it. Equal to, okay. Chloe, why is it equal to? Because it's a closed circle. Any questions over that? Okay, so we're going to put it all together for our piecewise function. F of x equals our big bracket. You start with the first equation we found, which was the 1x plus 3. And you just take that beginning part, x plus 3, semicolon, and the domain. Negative 4 is less than or equal to x is less than negative 1. Then you do the next one, which was our quadratic. So we just take this part of it. We don't need the 1 in front of it, just like we didn't need the 1 in front of the slope here. So it's just x minus 1 squared minus 3 with our semicolon. And then our domain, negative 1 is less than or equal to x is less than 3. And then the green, our final one, was y equals negative 1/2 x plus 4. So I put negative 1 over 2x plus 4, semicolon. And it'd be x is greater than or equal to 3. And that is our whole equation. We're going to do another one. We're going to get this. Okay. Okay, next one. Label 1, 2, 3. This is going to go a lot faster. You're going to be kind of shocked here. So class, is that first one linear or quadratic? Quadratic. So we need to find the equation y equals a times x minus h squared plus k. Okay, everyone find the vertex for me. Oh, write it down. Jacob M., what did you get for the vertex? Very good. My vertex is -4, -2. Did anyone get the A value? Question? 1. Okay, remember that first step. If I go to the right or left 1, how far up did I move? That's my A value. So my A is 1. Plug it in. Y equals 1 times x minus a -4 in here goes to +4 squared and then -2. And the domain. Everyone try to find the domain. Everyone's writing something down. Haley D, what'd you get? Mm-hmm. -3, very good. Okay, the -6 right here, and it has the open circle, so it cannot equal it. And then here where it ends, my x value is -3, and that is a closed circle. So it can equal it. Any questions over that? Okay, I want you guys to write the equations in the domain for 2 and 3. Help each other out, work in your pairs. So our line is y equals 2 because it's a horizontal line. The domain, it starts at -3 and it ends at 0 for x. The x value is 0 here. Don't give me the y value of 2, give me the x value of 0. It cannot equal -3, but it can equal 0 because of our open and closed circles. The next one, my slope should be 2 because I'm going to go up 2 and over to the right 1. Up 2 and right 1. My y-intercept is at 1, So that's why it's y equals 2x plus 1. The domain. It doesn't have a start and a stop. It just has x. It starts at 0, and it goes on for numbers that are greater than 0 for my x value. Okay, so now I have to put it all together and get one big piecewise function. So we're going to have f of x equals our big bracket. We have our first equation, the x plus 4 squared minus 2 with my domain of -6 is less than x is less than or equal to -3. Okay, then I have my next one is just y is 2. So I just put the number 2 there. I put my semicolon, and then -3 is less than x is less than or equal to 0. And then my last equation is the y equals 2x plus 1, semicolon, x is greater than 0. And that is my wonderful piecewise function. Okay, please get out your homework. We're on 5.1. Okay, we have these. Just explaining what's happening in this graph. On the back is where we're actually writing the equations. Everyone's going to work on number 8 right now. We're working on number 8. There's only 3 of these problems that you have to do for homework. I don't want anyone to tell me it was too hard. You guys can do this. We're going to try really hard to get this done. So let's work on number 8 right now.